Oh, who's the bestest girl in the whole world? Who's the smartest little doggy in the whole wide world? Who's the best little doggy? Are you? Oh my gosh. Winnie, scatter. You're not even that smart. Well, hey there, guys. It's Mr. S, back in the tackle shop. Time to talk about probability. Probably my all-time favorite mathematical concept. This video is going to be quite a bit of talking. I'm going to write down some stuff on the marker board, but mostly we're just going to talk about probability. I wish so badly that we were in class so that I could really teach this the way that I want to, because like I said, it is one of my favorite things in math. Let's start by the word probability. How many times have you gotten this answer to a question? You know, say you want to hang out with your buddy and you ask him, I'm going to choose one of my buddies. I'm going to say Micah. I'm going to say, hey Micah, want to come over and hang out with me? Micah might say, probably. What does that mean? Well, to Micah, probably means, yeah, more than likely I'm going to do it. Well, more than likely, that's a math word. Those are math concepts. Micah's telling me that the likelihood of that event happening is probable. Probably. Probable, probability. See where I'm going with this? Anytime somebody's told you probably, they were telling you that that event had a more than 50% chance of happening, or was more likely to happen than it was not to happen. See, that's really what probability is. It's the likelihood of an event. I think that people get probability and statistics really kind of confused. In my understanding, and I'm going to give you my simplest math teacher definition. Probability is only the likelihood that something is going to happen. So I can say anything. I could say a coin toss. I could say... Okay, so probability, like I said, is only the likelihood of that an event will happen, where statistics is basically the analysis of events that are grounded with probabilities. So it's kind of more of a holistic approach. You know, statistics incorporates probability theory. Probability theory, once again, states how likely an event is to occur. Well, some things we need to think about are how do we measure it and why is it important? Well, the first disclaimer that I want to let you know is that this is probably one of the most widely misunderstood concepts in all of mathematics. It's measured most often in a percent, but really we can measure it from a 0 to a 1. I'm going to write that down. That's important. So we can measure probabilities in a 0 to a 1. Well, let's take the extremes. Right from the beginning, let's talk about the extremes. Let's talk about a 0 likelihood event. We call it impossible. I can think of one right now. The probability that Mrs. Flairman doesn't talk at all for a whole 9th grade Algebra 1 class is 0. It's impossible. It would never happen. That event would have a p-value of 0. Impossible. Miss Flairman will always talk in class. Always. It's just a joke, guys. But it's pretty true. It's impossible for Miss Flairman to not talk in class. So we would give that a value of 0 in terms of probability. Now let's talk about something that's certain. 100% certain. Let's see. I'm going to go fishing within the next 3 days. That is a 100% probability. Rain, sleet, snow, I don't care what it is. I'm going fishing. We call that event certain. So we have certain and we have impossible. Winnie's having a snack over here. So if you hear some crunching, that's just Winnie eating her dinner at whatever time at night. Oh, Mom, she needs water. We'll get that after this video. So we have impossible and we have certain. Never going to happen and definitely going to happen. Then we have everything in between. Let's try to think of something that is exactly in between. BRB. Sorry guys, had to get Winnie some water. She's doing good now. So we talked about impossible events, Miss Flairman not talking for a whole class period. and certain events, me going fishing. Let's talk about something right in between, because for every event that's not certain or impossible, we must assign it a value. So let's talk about a really, really simple one. Let's talk about flipping a coin. All of you are already knowing, Mr. Saucer, nobody cares. Flipping a coin is a 50-50 shot. You're right, but let's assign it a probability. We're going to call that 0.50 on our scale from 1 to 10. Now, we all know that to be 50%. We call this, in probability, equally likely. We would say that the odds of getting heads or the odds of getting tails are equally likely. Now, this to me really is where a lot of people break down in probability, because there are two types of probability. There's experimental and theoretical. Experimental probability is what happens when you actually flip that coin. We all know that theoretically, a coin only has two sides, heads and tails. So we'll either get heads or tails. So the theoretical probability over here is 50%. But if we did it 10 times, we might get 6 out of 10, which would be a probability of 0.60 or 60%. That's kind of the weird thing about probability, and something that people don't understand. Here's another probability issue for you. And I've heard people in a professional environment say this. It's true that 53% of all marriages end in divorce. Well, what's not true is that you are 53% likely to get a divorce. What's also not true is that if you look at me and then you put another person next to me, that one of us has to get divorced because the odds are 50%. That's just not how probabilities work. What it says is that if we were to create this experiment over a long haul, we would get close, or probably always continually be getting closer to theoretical probability. That's called the law of large numbers. And there was this really smart guy named Brunelli who, I think he was like Italian. He was like an Italian mathematician. And he said that the more times you conduct a probability experiment, the closer that experimental data gets to theoretical data. So with our coin flip example, if we flip the coin 10 times, we might actually get all heads. Really, really unlikely. Not close to theoretical probability at all. But if we flip it 10,000 times, we're probably going to start getting close to that 50-50 number. So again, just remember, probability is measured between a 0 and a 1. A lot of times we look at it as a percent, and it is only a tool used to measure the likelihood of an event. It doesn't tell you that that event will or will not happen. Stay safe out there, guys.